So now let's look at an example where we're using this second version of the chain rule. So use the chain rule for two independent variables, to find the partial derivative of w with respect to s and the partial derivative of w with respect to t for the function w equals 2xy, where x is s squared plus t squared and y is going to be s over t. So we're revisiting the example from the last video, but now we're going to use the chain rule to find these partial derivatives here. So the partial derivative of w with respect to s, by the chain rule, it's the partial derivative of w with respect to x times the partial derivative of x with respect to s plus the partial derivative of w with respect to y, partial derivative of y with respect to s. So let's plug in the partial derivative of w with respect to x. Go up here to w. The derivative with respect to x would be 2y. Now look at your x equation. Take the derivative with respect to s, and it'll be 2s. Okay, take the derivative of w with respect to y. That'll be 2x. And then take the derivative of y with respect to s. It would be 1 over t. Now, you are going to have this extra step where you've got to plug in. You need to only have s's and t's in your equation. So you need to substitute in for y and x. So y was s over t, and x was s squared plus t squared, 1 over t. So you could leave it like this, or if we simplify, let's see, 4s squared over t plus 2s squared over t plus 2t cubed, or sorry, 2t squared over t. So if I combine this together, you would get 6s squared plus 2t squared over t. And if you compare this with what you got when you did substitution, you would see that that is the exact same thing you got. And then finally, I need to find the partial derivative of w with respect to t. So using the chain rule, it's the partial derivative of w with respect to x times the partial derivative of x with respect to t, partial derivative of w with respect to y, times the partial derivative of y with respect to t. And we found these first partial derivatives here. We found those in the previous part. So let me say that the partial derivative of w with respect to t is going to be, so this was 2y, and this part was 2x. So go back to your x equation now. So for this one, go back to your x equation and take the derivative with respect to t. Take the derivative with respect to t here. You'll get 2t. That's what goes here. And then if you go back to your y equation right here, take the derivative with respect to t, you'll get a negative s over t squared. And again, you've got to replace this y and this x, right? Y was s over t. X was, I'm going to replace it by s squared plus t squared. So if I simplify, this will be 4s minus 2s cubed minus 2t squared s. And that's all going to be, so plus a negative here. That'll all be over t squared. So if I got a common denominator here, these two terms would simplify because they both have an s and a t squared in them. They're going to simplify down to 2st squared minus 2s cubed over t squared. And there's my answer. And again, if you compare this with what you got in the last video, this is the partial derivative of w with respect to t, you'd see that this is the exact same answer that you got back in that video. But instead, we're using the chain rule now to find this partial derivative.